Okay, good evening. This is Professor David J. De Los Reyes. Okay, my next topic for tonight will be a continuation of my long video format discussion on trigonometry, and I am now on lesson number 30. Okay, what's up, guys? This is one of the most interesting topics under the study of trigonometry, that is the cosine of the sum and difference of two angles. Okay, let's proceed. The subject matter for tonight will be trigonometry, lesson number 30. The last time around, I've done lesson number 29, an example problem on the so-called expansion of the sum, sine of the sum and difference of two angles. So for tonight, we will be deriving the two more formulas needed under the study of trigonometry, that is the expansion of the cosine of a sum and difference. Cosine of a sum and the cosine of a difference. Okay, let's try to derive the two next identities. For the figures, we still use the same figure as the last time around. I just brought out four right triangles from the circular figure on lesson number 28. So this will be the first right triangle. This involves angle A. The corner notations are actually O and Q. This is still another triangle with the given angle A. This is different from this one, but their angles are actually same. These two angles was derived from the circular thing, the figure on lesson number 28. This is still angle A, this is corner P, R, and Q. And QR, if we try to go back to the circular figure, this is actually equal to MN. Okay. For the third right triangle, it will be angle B now. And the corner notations are actually OQP. Okay? The largest right triangle will be the one which is the solid line, not the dotted line. The solid line is actually, the total angle is actually the sum of angle A plus angle B. Okay? So the corner notations of the angle A plus B is actually O and P. And I inserted this what you call this dotted right triangle. This is actually angle A. This is what is this one. I inserted this one over here because later on, I think this will be OM. This should be M. Should be M. Right? This is M. I placed the dotted right triangle because later on there will be some subtraction of distances, which is O and this should be, sorry, this is M, this is M. Right. There will be subtraction of distances, and I want to show how the distances are actually subtracted. Okay, let's try to derive the formula. We will take the cosine of angle A plus angle B. If we try to take the cosine of the sum of angle A plus angle B, forget for the meantime the dotted right triangle. Cosine will be, okay, OM, okay, over OP. Okay, we agree with that one. Considering the bigger solid right triangle. From the figure, okay, OM is actually ON minus MN, right? The total distance OM is actually ON minus MN, okay? So this subtraction here actually emanates from this. That's why I brought out this the dotted right triangle. That is the value OM is actually ON minus MN, right? So we agree with this one. This is still over OP. Okay, there are two numerators with single denominator. We could distribute the single denominator. So it will be an ON over OP minus MN over OP. Okay? This one here, if we try to compress this one, it is this. But if we try to expand this one, this will be the expansion. Okay? Then we will do some algebraic manipulations. I will rewrite ON. Right? Am I still on camera? I will rewrite ON. Then I will rewrite OP on the denominator. Right? Then I will introduce OQ over OQ. Because OQ over OQ is actually 1. This is actually 1. But we could do it. Right? There's no violation on that one. Under the rules in the so-called algebra concepts, if we try to multiply the numerator by same number, we should also multiply the denominator by same number. We do not change the value of the fraction. And for the second one, that is Mn, I will rewrite Mn. Okay. Then I will rewrite OP. Then I will introduce a PQ over PQ. Because PQ over PQ, this is actually equal to 1. Right? Like what we did on the first one, there will be no violation here. We introduce OQ here, we introduce PQ here. Right? But from the given figure, the value Mn, this one, is actually QR. This is actually QR. So I place it here, Mn is QR. This was derived from the circular figure. This right triangles was derived from the from the circular figure. We brought out 4 right triangles. So actually this PQR emanates from the circular figure. Okay. If we try to notice it, the ratio ON over OQ is actually cosine of A. How's that? The ratio ON over OQ is the cosine of this angle here. So that is actually angle A, cosine of angle A. And the ratio OQ over OP, where is OQ? OQ, this one. OQ, this is O, this is Q, this is OQ over OP is the cosine of this angle B here. So this next one here is cosine of angle B. This ratio here is cosine of the second angle. Minus, from the given figure, the ratio QR over PQ. QR, this is QR. And that is actually equal to Mn. Okay? This was derived from the circular figure. Okay? The ratio QR, okay, over PQ is actually sine of angle A. So this is sine of angle A. Okay? And where is PQ? PQ, the ratio PQ over OP is the sine of angle B. The sine of angle B. So these ratios here, 4 ratios, actually emanates from the 3 right triangles. Right? ON over OQ is cosine of A, OQ over OP is cosine of angle B, minus MN, and which MN is equal to QR over PQ is actually sine of angle A. And the ratio PQ over OP is actually the sine of angle B. So if we try to substitute these values now in terms of these fractions here, in general now, the cosine of the sum of 2 angles, cosine of the sum, A plus B, will be cosine A, cosine of B. If this is plus, okay, you now know the difference. Under cosine, if this is plus, this should be minus. But this should be sine of A, sine of angle B. I got a code on this one. And I still memorize it 33 years ago. For a cosine function, it will just be simply cosine, cosine, sine, sine. Right? Cosine, cosine, sine, sine. If this is plus under cosine, this should be minus. Okay, by following that code, I still remember it after 33 years. But since I could derive it, there will be no problem. Okay, I got the code, I could derive it. So good for me. So in general now, the cosine of the sum of any angle A plus angle B will be the cosine of the first angle, cosine of the second angle, minus the sine of the first angle, sine of the second angle. So the next one that we will be deriving will be the cosine of the difference. Cosine of the difference. What will be the, so what is called this expansion supposed to be? It will still be cosine, cosine, sine, sine, but there is a problem with the sine. For the difference, if this is minus, for cosine, this should be plus. Okay? It's up to you to make a code on that one, so you could still recall it after 33 years like me, right? Okay, let's try to derive this formula here. To derive therefore this formula, we'll place here in general. In general meaning, let's try to replace A and B for the meantime by the value x and y. In general, not considering A and B for the meantime, we'll just consider x and y. Cosine of the quantity x plus y, following this will be cosine, cosine, sine, sine. If this is plus, this should be minus. So this should be cosine of x, cosine of y, minus. If this is plus, this will be minus. Sine of x, sine of y. Okay, let's try to derive this one. If we now try to place x to be equal to a, we don't change the sign of a, it will still be plus. How about if we try to replace y by a value negative b? To make it a difference, really, right? So if we try to replace x equal to a and y equal to minus b back here, what will come out? This should be cosine open bracket. We replace x by a, so this will be a. Plus open quantity, what will be y? Y is actually open quantity minus b close quantity close bracket equal to cosine of the first one. The second one is the cosine, the second one is actually instead of a plus b, it is negative b. Cosine open quantity negative b, right? Minus sine of angle A, sine of open quantity, okay? Negative b close quantity. If we try to take the equivalent of cosine of negative angle b, it should be positive cosine of angle b. It is this. Okay? And the sine of negative angle b is negative. There's a negative sign over here. Sine of angle b, it is this. Okay? So if we now try to replace this cosine of negative b by plus cosine of angle b, and the sine of open quantity negative b will be negative sine of angle b, okay? We derive now the third formula under the sine of the second formula under cosine. Therefore, in general now, the cosine of the difference a minus b will be the cosine of the first angle, cosine of the second angle. If this is minus, this should be plus, sine of the first angle, sine of the second angle. Cosine, cosine, sine, sine. If this is minus, this should be plus. How come it is plus? It is like this. We substitute this value here by a negative sine b. So a negative, negative, this will now be plus. Okay? That's why if this is minus, this should be plus because there was a minus here. But since the sine of a negative angle will be negative sine of that angle, a minus and a minus will be plus. So the second formula on how to take the cosine of a difference will be cosine of the difference a minus b will be cosine cosine, sine sine. If this is minus, this should be plus. So in general now, this should be cosine of angle A, cosine of angle B, plus sine of angle A, sine of angle B. And this plus cosine of B and minus sine of B actually emanates from this one. If the second angle is a negative B, it should be measured clockwise with reference to 0. So this is negative B, right? The real part or the horizontal part is plus. the vertical part is downwards, it's minus. The hypotenuse is always a plus. So if we try to take the sine, proper sign of the sine function and cosine function, we'll be using this one. For a cosine of negative of angle B, what's cosine? It is adjacent over hypotenuse. So this should be a plus over a plus. A plus over a plus will be a plus. So cosine of negative of angle B will be plus cosine of angle B in this case. Second one, if we try to determine the sine of the sine function, sine of a negative angle B will be, sine is actually opposite over hypotenuse, right? Because considering this angle, this is opposite side. So it should be the ratio minus, okay, we are just taking note of the sign over a plus. A minus over a plus, algebra, that's a minus. So sine of negative angle B will be minus sine of angle B in this case. There is a negative sign over here. So a negative sign here plus a negative sign here. That's why the operation here is plus. Okay. Okay, that's it, guys. This will now be the so-called equivalent of the cosine of the sum and difference of two angles. And this will be an additional two trigonometric formulas. Okay, good evening from Los Angeles. Professor Derivation.